Okay, so we are going to just talk about what we will be doing for this week, and then I'm going to be showing you some information that you're going to need for the test. So when you go into this next week's assignments, the EMS video and notes are going to be the first assignment for you. It's really important to go through both this video I'm making now, which will be attached to this assignment soon, as soon as we're done with it, and go through this PowerPoint here, which is going to give you information or answers you need to know for the test. So the first thing is this publication here that says Electromagnetic Spectrum Foldable. It is using a publication which is a Microsoft Office. It's part of Microsoft Office. So if your computers do not open it, you may be able to just click on the preview. And sometimes the previews don't work in these just because they're not the right format. But if it doesn't work and you can't open it, I will be actually showing it to you on the video here in a second, what it looks like. But if you can open it, you will see it open to this, which is what I just showed you that I had printed off. You can print it yourself if you have the ability to, and you can follow what I do and write on it and then use it as notes. Or you can just use these notes that I'm doing and take the same information down in your notebook. I would just make sure to write some stuff down so you have it in front of you for the test. The back side of the publication is a reminder of the parts of a wave. So the crest, amplitude, trough, and wavelength, there's some things that you're going to have to remember for the test as well. So yes, that's still part of the waves because electromagnetic spectrum involves all the different types of waves of light. So that's what we're talking about now. So if you can print it and follow along. If you cannot, you can just write it down in your notes. The second part of the assignment is to look at this PowerPoint. So I know for sure these open up in the previews. So when you click the little magnifying glass and it opens in the preview, you can even make it bigger if you like to have the full screen. And then as you scroll down, it's going to go through each type of waves for the electromagnetic spectrum. Most of you have done a Google Slides or a PowerPoint on this yourself, so that information is going to be helpful. But my information is going to be directed towards what you actually might see as needed for the test for answers. So I would write some of this down or have it available to use during the test. If you did print this, these boxes are places you can write that information down. So if we were in class, we'd actually all have a copy of this and be doing it together in class, but obviously we're not there. So that are the two like study guide type things that you're going to do that I am giving you information for. The next assignment, if you click next at the bottom, is a Quizlet. The Quizlet is going to give you all of the important vocabulary that you should use to study and some conceptual stuff as well. So most of these that are embedded in here are different games that you can use. So you can kind of go to this choose a study mode too and change it up if you don't like the game. But I made some of those there, or you could just click the actual Quizlet link and go into the Quizlet itself. And if you like to just read the terms and the definitions, you could do it that way too. So whatever way that you feel you are most comfortable with, make sure you read through these or use them as a study guide so you know that you have the answers when needed for the test. Okay, so after the Quizlet, then you would take the test. So take the notes down and then go to the Quizlet, make sure you use that to study, and then I would take the test while you're fresh in your mind. So the test will be available the 15th through the 17th. I'm making it available for 2 straight days. So kids that need to get on at any point in time can get on and take the test after they've done the notes. Okay, so the next part of the notes would be, what do I need you to know about this section in the middle of that publication? So this talks about the different regions of the electromagnetic spectrum, and each of these are a different type of wavelength. And they're important because they are different in their properties, and those are the properties that I want you to know for the test. So you can see it tells us the different regions. So there's 7 regions. It also kind of gives us a wave to show us that as we go across the spectrum, the wavelength gets shorter. So you can see the wavelength, the distance between waves, and then down here they're much shorter. Okay, the wavelength gets shorter as you go across, but the frequency, which remember is the number of waves per second, the frequency gets higher as we go across. So that's sort of demonstrating that part. And then down here, it sort of gives you a picture to show you that radio waves can be about the size of buildings or humans. They can be huge. Whereas you get down to gamma rays, and the gamma rays, the wavelengths can be as small as an atomic nuclei. So very, very small wavelengths. Okay, so we're going to talk about those, and then if you can write those down somewhere, you could take the test and you'll be ready to go. So we're going to start and talk about this side of the spectrum, the radio side versus the gamma side, and everything in between just follows that order. So on the radio side, we just talked about it, we have a long wavelength. So you want to remember it has a long wavelength, which then on this side, it's going to have a short wavelength. And remember, the lambda sign is wavelength. So if you want to abbreviate the lambda sign, you can. And then we talked about frequency. Down here, we have a low frequency. So there's many or much less in terms of the number of waves per second. Where over here, we have a high frequency. So you can see the waves per second are much higher. Now, obviously, this is not depicting the true waves per second. Their wavelength is so small that we wouldn't even be able to see the separation between the waves if we were really talking the wavelengths of gamma rays. Okay, so frequency, wavelength. The other two things we don't talk about a lot are temperature and energy. We know that waves are transmitting energy. That's what a wave is. It's taking whatever energy and transmitting it to its source or through its source or whatever it is. So sound waves we talked a lot about. That's an energy that is transferring, and we're hearing it in our ears, and it takes a medium to transfer sound. Light does not need a medium. Light waves can travel through a vacuum or empty space. That's why the light from our sun can get to our eyes or here on Earth, because that light can travel through space or empty space in a vacuum and not be slowed down. It'll still travel at the speed of light. So that's really important to know the difference between those two, sound and light. Okay, the other two things, temperature and energy. So we're going to talk about energy. Well, down here, these are going to have a low frequency, so we're also going to have a low energy. So radio waves have the lowest amount of energy. That means down here we have a high energy on the gamma side. So energy is important because energy is like what is transferring. So high energy can be very dangerous for humans. We don't want something with high energy penetrating our body like a gamma ray. High energy can penetrate dense materials. So dense materials that includes things like our skin, our muscles, our bones, down to our cellular level. So this can be very damaging if we're exposed to these higher energy frequencies. And then we go down here and we're low energy and they don't penetrate. You might have been driving before and your radio suddenly goes out when you're going through like maybe a canyon or a mountain range area where there's blockage, and these radio waves don't penetrate those very easily. Therefore, you might not get radio. Your radio will get staticky or whatnot. Okay, so the higher the energy, the more dense of an object it can penetrate. So that's dangerous for us. We don't want that. X-rays, we know they penetrate through our skin and they take a picture of our bones. So we use those a lot, but we don't want to be overexposed to X-rays for the same reason. The more that something penetrates into your body, the more damage it can do to your cells. Okay, and we also know that UV can give you cancer if you're overexposed, and you can get skin cancer. So you want to make sure that you're only exposed to the right amount. You need ultraviolet radiation to make vitamin D. But if you get too much of it at the wrong time of the day when it's out a lot and you're getting sunburned, then that can cause problems. So this one, you need a fine balance. Okay, so that's the energy. And then we'll talk about temperature. So energy and temperature kind of go hand in hand. If you have something moving very slowly and there's a low energy, the temperature is also going to be low. So I'm going to put it down here because I have space. Low temperature. And then on the opposite side, you're going to have a high temperature. So you got to think about, as you increase the energy, you're going to have an increase in the temperature. You can even think about that as if you rub your hands together, you know that the low friction is going to cause, you're not going to feel a higher temperature, but speed up the hands and suddenly you're going to have a higher temperature because there's more energy. Okay, so that kinetic energy is going to be turned into thermal energy. Okay, so those are some really important sides. So I will talk about on the test, like which region might have low energy and which region might have high energy. And I'll be referencing some regions, and usually the gamma, the radio, and I might pick another to throw in there. So make sure you know which side is the highest and lowest of those. And I kind of remember this side because they're all L's, long, low, low, and low. So the radio side has all long, low, 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 all L's. This one doesn't have the H because it's short, but you get the idea. Okay, so the other part of the spectrum that's really important is this visible light spectrum. This is the only part our eyes as humans can see. Now, when you get into different parts of the spectrum, there are animals out there or insects or whatever that can see in the ultraviolet or infrared part of the spectrum. And we cannot as humans. We see in the visible light only. So if we break visible light down, we know that visible light comes in as white light. So there's a little demonstration here of a prism. Goes in as white light, and then when it gets through the prism, through refraction, it's going to show us all of the colors of the rainbow. All of the colors would be Roy G. Biv, that's our acronym, red, orange, yellow, green, blue, indigo, violet. Okay? So I'm going to break down the visible light spectrum into Roy G. Biv, just for the sense of talking about these same properties. So Roy G. Biv, red, orange, yellow, green, blue, indigo, violet. So there are also 7 colors in the visible light spectrum that we talk about. Now they follow the same as these properties over here, depending on their size. So I always remember that the red is on the radio side, R and R, and the red side of the visible light spectrum is going to have a longer wavelength, a lower frequency, a lower energy, and a lower temperature. So that's the red side. And you might remember red shift and blue shift. They look more red if they're moving away from you because they're stretching out the waves as they're moving away. The Doppler effect, remember? And they're stretching out the waves, making you see more red. So red has a longer wavelength, and that is this side of the visible light spectrum. On the opposite side, the violet side, and sometimes we just call it the blue side because blue, indigo, and violet, while they're definitely different in color, people just sort of call that the blue side because it appears blue to them. So when we talk about blue shift and a galaxy is coming towards us, it's going to crunch up those and it's going to make a shorter wavelength or a higher frequency, which we see more on the violet or blue side. So a galaxy would be blue shifted if it's coming towards us. Okay, so the violet side, now I also can remember that, oh yeah, the violet side, this is called ultraviolet because it comes right after the visible light part of the violet, part of the visible light spectrum. So this is ultraviolet. And then on the other side, look at this, infrared, happens to come right before red on the visible light spectrum. So infrared and then the visible light spectrum, and then ultraviolet follows the violet side. So that's kind of a good way to remember it. And then the violet side is going to have a shorter wavelength, higher frequency, higher energy, and higher temperature. So these will need to be known, that acronym there, Roy G. Biv, and that it's part of the visible light spectrum when you have white light separated. And that is the part of the wave or the electromagnetic spectrum that we can see. And it's around, the red ranges in the 400 nanometers to about 700 and some nanometers for the violet side. And that's about what we can see in wavelengths. Okay. So that is really all I need to talk to you about on this. Like I said, if you are able to print this, remember my printer is terrible, you can go through that PowerPoint. Again, that PowerPoint is on Canvas and it's right before the Quizlet. So the PowerPoint is going to give you some information that you definitely need to know. So remember, it's right here. You can open it and go through each one. And if you want to write it into, so you can go to gamma rays and then you can write that right into, it's the wrong one. the gamma ray box if you want to, or just write it in your notes if you don't have the availability to print this. Okay, so just remember all that stuff I talked to you about, or use this video a couple times to go through what it is that's important, and then you should be ready for that test, and then study that Quizlet as well. Okay, goodbye.